This video I shall tell you about infeasible solution of solving an LPP problem using Simplex. For that matter, I've taken an example: maximize z is equals to 3x1 plus 2x2 subject to constraints 2x1 plus x2 less than equal to 2, and we have a greater than constraint. So the artificial variable comes into picture only when we have a greater than constraint. So what I'll do is, in order to convert the inequalities into equalities, I would add a slack variable here for less than constraint, and for a greater than constraint, because something is greater, so I have to deduct the surplus variable, add the artificial variable over here. So in order to make this equation equal, I would do this, okay, and I'll convert the inequalities into equalities. In short, for less than sign, you have to add something, so the addition is the slack variable, and when you have to deduct something, the deduction is the surplus variable and the addition is the artificial variable. Now for the objective functions, in my previous video I had talked about the artificial variable. So in maximization case, the value of the artificial variable is minus m, and in case of minimization case it is plus m. So I'll be adding that to the objective function: 0s1, 0s2, and for the maximization case, minus ma1, and I'll enter these values now into the matrix. So for this, the plus values, the variables with the plus values, s1 over here and artificial variable over here, so these are always my basic variables. So s1 for the first equation and a1 for the second equation, the value is 0. The value for the objective function in this case is minus m. Same, I'll enter these values from the objective function, the cj row 3, 2, 0, 0 and minus m. For more details, you can watch my previous videos on these. So these are the values 2 and 12 that we write in the quantity column, and these values we enter into the equations. So 2, 1, 1 and 0, and here 0, and here 3, 4, 0, minus 1 and 1 over here. So this is how we enter the values. Now I would simply find the zj by multiplying these. So in this case it is minus 12m, it is minus 3m, it is minus 4m, it is 0, it is m, and it is minus m, and then this is 3 minus 3m, so cj minus zj, so this is 3 plus 3m, 2 plus 4m, 0, and this is minus m, and this is 0. Now I'll solve the sum. In case of maximization case, I'll enter the value which is the biggest, since it is called the big M method. I've talked about this in my previous video. Big M, why it is called big M method? Because m has an infinitely large value. So if I choose to enter the largest variable as my key column, so 4m is bigger than 3m, so I'll choose this because m has an infinitely large value. While talking about the minimum ratio column, the formula is quantity divided by the elements of the key column. So what we do is 2 divided by 1 is 2, 12 divided by 4 is 3. इधर से हमने छोटी पॉजिटिव वैल्यू को की रो लेना होता है, विच इज़ द आउटगोइंग वेरिएबल ऑल्सो, एंड द वेरिएबल एट द इंटरसेक्शन इज द की एलिमेंट. सो now the entering variable is x2 and the exiting one is s1. Now x2 in the next table would replace s1 and a1 would be at its place. In the objective function, the value of x2 is 2 and here it is minus 1, and then I'll, for the key row elements, what I'll do is, the key row elements are always the elements divided by the key element. So it is 2, 2, 1, 1, 0, 0. And for the non-key row elements, we repeat the previous row, that is 12, 12, 3, 4, 0, minus 1 and 1, and minus, 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 minus. We enter the key row that is now there. This is 2, 2, 1 1 0 0. Multiply it with the element corresponding to the key element. For this row it is 4. So I'll multiply the entire row with 4, and making this calculation, 12 minus 8 is equals to 4, 3 minus 8 is equals to minus 5, and so on. I'll reach at my values over here. So this is minus 4, this is minus 1, and this is again 1. So I'll enter these values: 4 minus 5, 0, minus 4, minus 1, and 1, and then multiplying these. So what I do is 2 multiplied by 2 plus 2 multiplied by 2 plus 4 multiplied by minus m. So this comes to be the value of zj. So this is 4 and minus 4m, and similarly this 5m plus 4, this is 2, this is 2 plus 4m, this is m, and this is minus m, and I'll the objective function 3 2 0 0 and minus m, and this is then I'll deduct cj minus zj. So 3 minus 5m plus minus 4, so this comes to be minus 1 minus 5m. Here 2 minus 2 is 0, here minus 2 minus 4m, and this is minus m, and this is 0. So this is cj minus zj. So from amongst these values, this is the value, and these values, since all the values are 0 or negative, so I have reached at my solution. So in case of simplex, in maximization case, you reach at the solution when all the values. So in maximization case, you reach the answer when you get all the negative or 0 values, and in case of minimization case, when you reach all the positive and 0 values. So here we've reached all negative and 0 values, so we've reached at the solution. But why is it called an infeasible solution? Because the artificial वेरिएबल इज स्टिल परसिस्टिंग. हमारा आंसर आ गया पर आर्टिफिशियल वेरिएबल अभी भी सोल्यूशन का पार्ट है, जो कि नहीं होना चाहिए. सो इन दैट केस इट इज़ कॉल्ड एज एन इनफीजिबल सोल्यूशन. सो दिस इज कॉल्ड एज इनफीजिबल सोल्यूशन, राइट. सो इनफीजिबल सोल्यूशन occurs, solution is called infeasible when we have an artificial variable in the final simplex table. The final simplex table is the table in which we get the answer. So it is still persisting, the artificial variable a1 is still persisting, so it is called as an infeasible solution. So for more videos on special cases and other OR problems, stay tuned to my channel. You can also watch my other videos on my Instagram handle, and I would share the link of the same. And don't forget to like, share and subscribe. Thanks for watching.